Alrighty, nice and straightforward here. We're looking at calculating the surface areas and volumes of composite figures. Composite figures being objects made up of our basic figures that we've already practiced in this course when we worked with prisms and when we worked with pyramids. And the idea is, hey, you might say, well, hang on, we worked with cones as well, we worked with cylinders as well. I know, we've talked about that. A cylinder is like a circle-based prism. A cone is like a circle-based pyramid. We're going to handle it that way. We're not afraid of our circular bases here. So, prerequisite skills, you need to make sure you're comfortable with section 2.2a, working down. That is, you need to make sure you're able to follow along with my work. You need to make sure that you're comfortable with section 2.2b, that is calculating surface area and volume, along with using a formula sheet. We're going to use that formula sheet once more here. Again, I will emphasize the purpose of this course is not to memorize these formulas. You can always look them up in the future when you need them. The purpose of this lesson in this course is to be able to be comfortable using your formula sheet as we work forward, as we practiced in the last video. If you're not comfortable with that, make sure that you head back and review your ability to work on section 2.2. We're going to look here at example 1. Example 1 has a circle-based prism, that is a cylinder, sitting on top of a rectangular prism as well. So we're working with two prisms here. We need to calculate the volume, calculate the surface area. The volume is the more straightforward calculation right here. So I want you to consider, we've already practiced calculating the volume of a cylinder. We've already practiced calculating the volume of a rectangular prism. I want you to consider, hey, if I can calculate each of those, how would I calculate them together? Nice and easy, nice and straightforward. Well, the total volume, I'm going to use VT. That little T stands for total. The total volume is just going to be equal to the volume of the cylinder plus the volume of the rectangular prism. Easy. And you actually know how to calculate both of those. You can refer to your formula sheet. I encourage you, pause the video here, perform your calculations, come up with your total, unpause, see how I lay mine out, and then as we go forward in future problems, you can practice laying yours out just like me. So pause, unpause, see how you did. Good, so at this point, I have calculated the volume of my cylinder. That is pi r squared times the height of the cylinder. You don't necessarily have to put that little subscript in right here, but that's a nice way of keeping track. Hey, look, I'm working with two heights of two different figures right here. I'm going to label this the height of the cylinder, that one the height of the rectangular prism. And then I continued, I substituted in all of my values. I didn't have to show this middle step. And then lastly, I've shown my final answer. So I want you to make sure you're showing all of these steps. You're showing, hey, what's the way that I'm putting together these two calculations, and then the individual formulas, calculating the volume of the cylinder, substituting in our values, and then our final answer. And then working with the rectangular prism. Okay, so I'm working with length times width times height of the rectangular prism. I substitute in my values. It does not matter which one's which right there. I calculate that is 336. Again, this middling step right here, this is optional. I don't necessarily need to show that. And final answer, 477. Right now, I want you to take 5 seconds. Just consider, hey, what's missing from my solution here? There's something missing from this volume I've calculated. And if you said it's the units, if you said it's centimeters cubed, nice work. That's exactly what we need to make sure we consider when we're working with volume. Working with volume, we're always going to end up with cubic, or with cubed units, rather. So that is our volume. If we're working with our surface area, we could just take the same approach. Okay, well, our surface area, total surface area is going to be the surface area of the cylinder plus the surface area of the rectangular prism. And you might say, hey, that makes a lot of sense. It worked for volume. It should work for surface area. The problem is, surface area, remember, is all of the area surrounding an object, right? So if I calculated the surface area of this cylinder, then I would be calculating the area of the top of the cylinder, the lateral area around the cylinder, and the area on the bottom of the cylinder. Well, I actually don't really need to calculate that last one right there because that's not involved in the surface area of our total composite figure, because the bottom of this cylinder is actually touching the top of the rectangular prism. It's not exposed, right? And it's only the exposed areas that we consider when we're working with surface area. Likewise, if we consider the surface area of the rectangular prism, well, there are 6 faces of that. There's one front face right here, there's a side face, there's a bottom face underneath, there's a back face over here, there's a back face around this side, and then, and this is the key right here, and then there's this top face. And this top face, right, is a rectangle. It looks kind of like that. Well, this top face right here also has this circle that is not exposed, right? The circle, the exact same shape that we had from the cylinder above, because it's being covered by the cylinder. So what I need to do, if I'm going to calculate my surface area by adding up the 2 surface areas of the 2 figures that I already know that I'm working with, then I need to also make sure that I subtract the face that's sticking these 2 shapes together, and I need to make sure that I subtract that face twice, once for the cylinder, once for the rectangular prism. So in this case, I'm going to subtract, and that shape is a circle, so it's pi r squared. That's the formula for the area of a circle. And then, wait, how many times am I subtracting that? Once for the cylinder, once for the rectangular prism, so I'm subtracting 2 times pi r squared. At this point, because there's not a whole lot of space, you're going to see me set this up using another approach, which likely you might be more familiar with right here. I encourage you here, pause the video, calculate the surface area of the cylinder, calculate the surface area of the rectangular prism, put them all together using this formula right here. Don't forget to subtract the area of the circle twice. Pause, unpause, and see how you do. Good, so at this point I've calculated the surface area of the cylinder. I've copied out the entire formula. I've substituted in my values. I have my final answer right here with my units considered. When I'm working with surface area, my units are going to be squared. That's always the case. Then what I did is I calculated the surface area of my rectangular prism. I showed the formula, I showed my substitution, I showed my final answer with the units included. And then what I'm doing, I need to make sure that I input in those values into that original equation that we had. So I'm just going to take that equation that we had, I'm going to bring it right down for us to work on, and then we're going to substitute in all the pieces that we know, because we do know that we've calculated the surface area of the rectangular prism. We do know that we've calculated the surface area of the cylinder. Now we're putting it together while subtracting that area of the circle as well. So I'm working with something that looks like this, where again, I've substituted in all the pieces that I know, I've worked my way forward, I've shown my steps, and I've shown right here how to calculate that subtracted side length as well. So if you're looking at all this hard work we've done, most of it actually isn't new. The only new piece that we have worked on right here is setting up these equations when we're putting them together. That is, we set up our total volume formula over here for this composite figure, and then we set up this total surface area formula here when we set up our composite figure, and that skill, that's going to be different every single time depending on the way that your figures are put together. Sometimes the figures are put together just like this one, where we have one figure attached to another figure, in which case all we're doing for the volume, we're adding them up. For the surface area, we're adding them up, and then we're subtracting twice. We're subtracting whatever shape is connecting the 2 figures where the glue would be. So in this case, I have myself a cylinder, and somebody's come up to this cylinder, and what they've done, instead of adding another shape onto it, they've cut it out, right? So it's like they had a wooden stump, a cylinder, and then from that, they cut out the shape of a cone from the middle. So this time we can't just follow blindly the same pattern we followed last time. We have to use our logic. We need to take a step back and say, hey, instead of just adding up our 2 volumes, instead of just adding up our 2 surface areas and subtracting twice that shape that's shared, we're just going to take our time. We're going to make sure that we make decisions that make sense given the 3-dimensional figure that we're working with right here. I want you to pause the video, try and set up those first 2 formulas. The volume, the total volume, how are we going to calculate it here? The total surface area, how are we going to calculate it here? And then unpause and see how you did. Alrighty, so when we're working with our volume in this case, well, we recognize, hey, we set this up with the volume of our cylinder. That's where we start. And then somebody came and they removed the other one. So we're going to work by subtracting the volume of the cone. Nice and straightforward. The same way we describe this is the same way we calculate the total volume. When we're working with surface area, it's not the same thing. In this case, our surface area is actually really, really similar to the figure that we used last time. Because in this case, we have ourselves the surface area of the cylinder, and that is okay. Well, we still have all of this outside area that we're going to need to work with, except there's this removed hole from the top of the cylinder. So there's a circle removed from that top face. And that's one of our pi r squareds, right? And then we're saying, well, hang on, then we also have the surface area of the cone. And the cone, well, we still have this lateral side of the cone, but what's being removed, there's a hole in the top of this cylinder, there's a hole in the top of this cone, so again, we're going to subtract the circle from the top right here. That's why we're working to subtract 2 pi r squared right here, because it's like this circle is missing twice, once from each shape. So if you know that, I want you to use your formula sheet, pause the video, calculate all of these different pieces, calculate your total volume, calculate your total surface area, unpause, and see how you did. Good, so right here you can see I've calculated the surface area of the cylinder. That's in yellow right here. I've shown my work, right? I've shown that equation as it shows up on my formula sheet. I've shown the line when I've substituted in my values, and I've shown my final answer. And then I take that final answer and I put it way up here. Oops, it looks like I misordered those. That's all right. There, that's a little bit better. So I calculated the surface area of the cylinder way down here. I plugged it in to my formula way up top. And then I did the exact same thing with the surface area of my cone. I calculated it, I showed all of the lines that I need to show, I substituted in my value, I performed my total calculation, and I found these two answers right here. For volume, I'm working with 263.76. For surface area, I'm working with 270.04. And then we ask ourselves, hey, what's missing? Again, we need to make sure that we have those units, meters cubed in this case, for our volume, and meters squared when I'm working with my surface area. I'll need to be careful with these down here as well. Good work. So at this point, hopefully you're feeling a little bit more comfortable calculating volume and surface area of composite shapes as we're working here. What I want you to do for this third figure, I want you to try it on your own. I want you to come up with those formulas for the total volume, the total surface area. I want you to calculate all the pieces. I want you to put it together, and then I want you to unpause and see how you did. Good, we're here again. You can see we have it color coded. You can see the rectangular prism work here in green. You can see the triangular prism work here in yellow. We have used right here, you'll notice this shape right here. This symbol indicates that both of these side lengths are the same, so we can assume that we have a 5 meter long side over there. We can assume that this 6 meters is split up into 3 and 3 right there. As you're working your way forward, again, make sure that you are including, ready? Include your total surface area, your total volume formulas up here. Include your individual substitution formulas straight from your formula sheet. Include the numbers that you're substituting in next, and make sure for your final answer you have units included as well. Great, so if you followed along, I imagine you're feeling a little bit more comfortable working to find your volumes and surface areas of composite figures. Nice work.